Peter Grindrod from University of Reading. But he's from Scotland.
Good afternoon, everybody. Thanks very much to Stan and colleagues for giving this opportunity to talk to you all. Since it's St George's Day today, even though I'm talking about work with Scottish and Southern, I thought I'd just introduce the national flag. Okay. I work in the Centre for Mathematics of Human Behaviour, which is a research group at the University of Reading in the Department of Mathematics and Statistics. And broadly speaking, we work in areas where there are large amounts of data and therefore analytics required, generated by not machines, not synchrotrons, but people. And people are of bounded rationality, as we were discussing over lunch the other day, are awkward, inconsistent, inconvenient, and often, in the case of my friends, don't show up at all. So principally we work in sectors like energy, the stuff I'm going to talk about today. We also have a considerable amount of work to do in areas like advertising and digital media, and increasingly in other areas where there are large amounts of data like mobile phone communications and extends into security. My group, Centre for Mathematics of Human Biology, also has a spin-out company called Counting Lab. This is a lovely new website, so I'm getting used to putting this up there. And we're always looking for bright people to come and work for Counting Lab. And Counting Lab is a kind of interesting thing for mathematicians because it's a translational vehicle, really. We don't want Counting Lab to become part of operational activities with its clients or companies. We want Counting Lab to get stuff across the gap between the things that we discover and we publish in journals and actually the things that might ever become operational inside of companies. And so you need a little company like Counting Lab to kind of do some further research, translational research, or actually to produce proof of concepts or prototype platforms to try and demonstrate how new technology can be applied. So that's a kind of interesting area for all of us, and that's what we're doing at Reading. So today, in a matter of minutes, I'm going to explain a little bit about the Thames Valley Vision project, what we're doing there, which is set deep in the heart of Bracknell. So I'm also going to talk a little bit about some historical work on smart meters, which I'll show you some of the work we've done there and some of the problems that it presents. And I'm going to focus particularly on the last half mile of domestic supply. So really, I'm thinking about domestic users. Some of the things I say would apply to SMEs and things like that, but really I'm thinking about domestic consumers who in the next few years will all have a smart meter. Perhaps daily their smart meters will be polled, there'll be a national data centre company, and then that data will be whizzed off to the DNOs so that they can monitor how the networks are performing, and of course it'll be whizzed off to the supply companies who actually need to have their tariffs and make the charging and things like that. So big changes coming, data deluge coming. Now in every other sector in which I've worked over the last 30 years, the general truth about big data coming into commercial sectors is it tends to turn the sector upside down. And if you think about it, generally sectors start off as being really supply-centred. So you could think of retailers used to talk about supply chain management and category management. Telephone networks used to talk about getting more masts up and thinking about being supply-centred. Must keep the supply going, that's mission critical for us. And then when Tesco and others presented a loyalty card, they turned it upside down and they became customer-centred. And they worried about why people took things off shelves as opposed to how efficiently we can put things onto the shelves. And in that, those companies that embraced that idea generally grew and prospered. We've seen the same thing now going on in mobile telephony, where to be honest, they've sold us all a telephone and a half each now. So where are they going to get the shareholder value from? They're going to get the shareholder value by selling us more stuff through our mobile phones, through our iPads, through this convergence of platforms. And to do that, they have to become behaviour-centred. So you could think of maybe energy is going to go through a similar shift where as we get to know more about what the customer does, As we get to know more about why the customer demands or how the customer demands, there will be opportunities to build loyalty, to build relationships, to build trust, all of those sorts of things. But today I'm going to talk about some of the mathematical problems that follow on from all of those. By the way, we heard in Paul's excellent talk earlier on a little bit about economics. I've always thought that economists are a bit like sort of psychoanalysts. They're very good at telling you what just happened, but they're not very good at telling you what's going to happen tomorrow. Right? And here today we're going to confront the problem of inference and forecasting. What's going to happen tomorrow? So don't bring Sigmund Freud in and ask him what's going to happen to this girl in a year's time, because he won't tell you. And it was, so those three things there. I think it's in Predictably Irrational, very good book, where someone likens astrology, psychoanalysis, and economics as they're all the same. And it was David Hilbert who once said, even if you got the 12 most clever men in the world together in a room and gave them a month or a year to come up with something stupid, they'd never come up with anything as stupid as astrology. So a bit of that. We're going to talk a little about forecasting and then a little bit on how we're going to exploit these insights. So New Thames Valley Vision, it's a very exciting project. It's funded under Ofgem's Low Carbon Network Fund project. It's about a £30 million project. What we're doing there, we're trying to see what the value is of the data, whether we can make better decisions both in planning networks and operating networks. But nevertheless, Ofgem's focus for this fund is very much that, we're spending public money and there must be consumer benefits, customer benefits, there must be perceived benefits. And this isn't quite so obvious. I mean, if you talk to a lot of people in the energy company and you say, what's the benefit of all this, smart grid and da-da-da-da, and they say, well, we've done all this work, and so instead of there being racking up huge costs in relaying the network or improving the network, we'll be able to save a bit of that, so you won't charge you as much as we were going to. So that's a bit like me saying to you, well, I was going to come round next week and punch you in the nose, but now I'm only going to kick you in the shins. How do you feel about that? Is that really a benefit? We've seen in other sectors that actually when people shared data, when data got analysed, there were real benefits for customers. And so we have to think a little bit about that as we're going through this and try and track those. I'm going to do that one. This is where we're going to be. We're going to be in low voltage networks. Down at this bottom end, we're thinking about domestic things today. So we're not going to do any of this high voltage stuff up here. And today I'm not going to talk about these people, although many of these SMEs are more than 100 kilowatts. They're already on half-hourly data. And but really I want to focus on domestic use and planning. So our project is quite a complicated project, and it involves a number of partners. And you can see some of them here. So University of Reading, that's us, Bracknell Forest Council, and lots of housing stock in and around Bracknell. GE, those are Kema and EA Technology, two consultancies, and Honeywell, and their principal focus is on interfacing to building management systems, and there's a whole lot of other fun and games in that part there. GE really, as part of this project, are trying to produce next generation planning tools so they can plan for new housing developments and plan new networks and that kind of thing. And in doing so, they want to have better demand profiles or more realistic demand profiles. What are the challenges for these sorts of networks? Well, we've got to get more energy through the networks, really. Although people's total energy may go down, actually the share of electricity supplied through the grid is going to go up. And of course, the electricity network doesn't exist on its own. So just one quick example, which is a kind of worrying illustration of the sort of scenarios we want to think about. If you think about the take-up of electric vehicles, if we said, 10% of the nation can have an electric vehicle, that's fine if they're all spread out. But actually there's something called keeping up with the Joneses, the social network. The lady next door has got a new electric car. Oh, we better get an electric car then. So it's a good bet that electric cars are going to be all at one end of the street, or all at one close, and therefore probably on, some local networks, and won't show up at all on others. And then those people who live up the same road, who've all got an electric vehicle, they all go to bed at 11 o'clock on a Sunday night and plug the cars in. This is half-hourly data, different rhythms of the day. We're going to be looking at some of this in a way, and you can see straight away that for individual homes, it's very spiky, even at the half-hour level. Obviously, we're just showing half-hour offset data there. That's all that we're capturing, and that's, I believe, all that we'll be able to capture from smart meters when they're rolled out. But you can see, even with that half-hour smoothing, it's still very spiky, and there are big exceptions, and we can see these people got it going on all night. These people go to bed quite nicely and turn it all off. How volatile are local aggregations? So, just a thought experiment without actually looking at a network, because we've got it, we can make up networks. So we can put 200 people onto a network, add up their aggregate demand, and have a look at how forecastable it might be. And it turns out that with less than 200 people, if you've only got 75 households on a network, actually it can be these are normalised 30-minute variations. So what we're seeing is that probably there aren't really any good forecasting methods that are going to be helpful in forecasting those people up there, because they're just volatile and they may not be forecastable. So what I'm saying is that the law of large numbers doesn't kick in on these networks. We've got maybe less than 100 people on a network, and they don't mollify each other. If I want to forecast the nation, then maybe that goes up and down with Coronation Street or something like that. But here, I've got relatively small numbers of households on a network, and it's not going to look smooth at the local substation. It's going to look very, very spiky. And worse, all the people down the road, the kids all have their breakfast and all get on the same school bus. So they're highly correlated in what they do in a day. So they're not going to smooth each other out and stagger it out. And it's going to, might look like one big house in an extreme. Average 30-minute usage kilowatt hour for these 200 people. Some of these are using quite a lot of. These are actual patterns. The way to read this, it doesn't come out very well. This is day 1 through 7, so Saturday and Sunday are last, and these are the 48 half hours in a day. So that's midnight through to midnight Monday, midnight through to midnight Tuesday. And in these pictures, they're empty houses. We're just watching their fridge and freezer switch on and off, right? And these people at the top, everything's on all of the time. That's probably my house, thinking about it. These people, the weekends are pretty much the same as the weekdays. That's what it is to be old, unemployed. We need to do a behavioural segmentation with these people, and we're unsure at the moment how to do this. And we'd really like to produce something that wasn't about the asset, the type of house, or wasn't about the amount they demanded, but something about the behavioural patterns. And here I've just split it into 10. And this is old work done on EDRP data. But if we were a retailer, we would probably split it up into about 30, and we might have a hierarchy with, for reporting purposes, 10 segments, and then each one might split down into another 3. And that would allow us to talk about suitable portions of the population and talk about how they demand, how they, whether people do the same thing every day. So these people get up nicely here at 6:30 every morning. And these people late night on a Saturday night, just getting into 1 o'clock in the morning there. John Terry pops around my house there. This is what happens if you look at over a longer period of time. You can see that this is roughly summer through winter. There's a rick in the data there, so that's why there's missing points there. And you can see how consistent people are. So broadly, these people who are labelled black sixes up here, they're ultras. They are predominantly sixes, and they spend more than X% of their time in that mode, but they occasionally trade up in cold times. We can see people moving around. And so actually when we want to segment, we're now thinking about segmenting based on annual behaviour, then something about, say, for weekly or monthly behaviour, and then something about weekly behaviour or something like that, so that we can talk about the different types of behaviour. And then we can start to compare networks, because when we find some networks in distress and other networks doing very well, maybe it's because they've just happened to have, historically, they've developed the wrong sort of distribution of people, or maybe some of these people are particularly troublesome for us and they can only be met with headroom, in which case if we get too many of the wrong type of people on the network, then actually that network's going to struggle a little bit. So we're thinking about those sorts of behavioural things. And what we're doing in Bracknell is we're intensively monitoring some local networks. There's about 3 networks where we'll intensively monitor and try to monitor almost every endpoint on those networks so we can understand them. And then we're also going to monitor every substation in the whole of Bracknell. I think there are 300 substations or something like that equals the whole of Bracknell. So we can have a look at every substation. And in some way we'd like to traffic light all of the resultant low voltage networks. So we'd be able to say, well, some of these are in distress now and something needs to be done. Some of them we'll put on a monitoring list. We don't need to manage them, we just need to monitor them. And some of them it looks fine, there's no reason to be concerned. Hopefully 70-80% of them will be green and we don't need to worry about them at all. And we'd like to know what the drivers of that kind of escalation might be. Is it social? Is it behavioural? Is it to do with assets? Is it to do with just unfortunate consequences and those sorts of things? We're trying to find the drivers of poor behaviour. If you talk to supply companies, and they often like to use mosaic classifications for people, so this is what you get from Experian, welfare borderline, urban intelligence, twilight subsistence. Got any of those in today? Twilight subsistence, rural isolation, municipal dependency, happy families, grey perspectives. These are different types of people, and what I've done here is I've just laid out those 10 segments in rough order of usage. So these people are very heavy users. They're using far more than planners would have allowed for them. Planners would say, no, there aren't such people on our networks. There are. And actually some of them are grey perspectives and blue-collar enterprise. So the trends go the right way, but it's not all about your socioeconomic readout from Mosaic. Good news, you're not like your neighbours. It's not all about assets either. We've done some work where we've looked at distributions of usage and behaviour across similar assets, so very similar housing stock, that kind of thing, similar size of family in the same housing stock, how similar are those? So actually just knowing a socioeconomic indicator based on postcode and just knowing about the asset isn't really enough to try to predict individual homes' behaviour. The good news is we've got about 100 on each network. The bad news is 100 isn't very much when you've got 48 variables a day, 48 half hours in a day. So this is what it looks like if we look at the total system demand, sort of relatively smooth curve, still some problems in predicting some of that. This is what it looks like at the sort of 50 households. So a substation is looking at this sort of demand. It really is quite volatile. Now, forecasting down at a household level, we have to be careful what we mean by a forecast because, unfortunately, the PowerPoint hasn't shown the actual very well here. So I'm just going to draw this. I think what's going on here is that you've got an actual, which maybe looks like that, and you've got a forecast which maybe looks like this. And if you calculate the simple error norm of this actual minus the forecast, actually you would have been better to have forecast that. Because the reason is that if you forecast a peak and you miss, you'll get penalised twice. So if you have a forecast which doesn't forecast the peak at all, you only get penalised once. So it's going to do better. And so we're going to have that problem in spades unless we think about what the forecast is for. Here's some typical profiles. One of these houses is very volatile and actually very difficult to forecast. Another one of these is, the other two of these are relatively straightforward to forecast with naive means. So the point is that this is the sort of problem we have when we want to forecast individual households, and I'm trying to argue, slightly unfairly, but I'm trying to argue that it's roughly the same problem at the substation. It doesn't get much better with just 50 or 100 houses on. here are some examples like that where we've got actuals and we've compared a flat forecast to some two methods of forecast, naive forecast. Dotting is just using last week as this week. That does quite well with some houses. Doesn't do so well here. You must have had a party last week and didn't have one this week. The AA forecast is just a different type of adaptive forecast. But you can see that actually comparing actuals to you can't see the actuals there, but comparing actuals to forecast, actually there's some message to us here, and it says we've got to think very clearly about what we're optimizing when we're choosing forecasts. We shouldn't just go for it using an L2 norm or an LP norm. Actually, that won't necessarily work for us. So what kind of forecast would we like? What makes a good forecast, I should say? What I want to do is to think about forecasts where if we have a forecast which is actually, it's just 48 vectors, 48 numbers. It's a vector. And if we think about that forecast as giving us a kind of daily image, it might be that the actual, which I'm going to call x, let's get the x down to maybe that the actual maybe looks kind of like that. I mean, that's quite a good forecast in many ways because the forecast looks quite like it. I mean, it just needs shifting a little bit. Just needs those peaks shifting over a little bit, but it's pretty much got the magnitude and the number of peaks right. It hasn't got them quite in the right position. And so this suggests using a norm of the following type. It says that let's use a norm something like this. Let's use let's use the minimum of pi is going to be a permutation. So pi is a permutation on these indices. So I'm going to look something like the minimum of a sum of, say, f of pi of I minus xi to some high power, so it's on focus towards the peaks. That's an L4 norm. But actually what I'm doing is I'm saying, well, let's consider some class P for permutations, some class of permutations, and let's try and produce a norm which is the minimum within that class, a limited class of permutations, which tries to shift f about. It shuffles f about in such a way that it gets the best match under the 4 norm for x. So all I'm doing there is I'm just saying, well, let's allow a bit of elastic in the forecasting so that we can have what's going to happen then is that forecasts like this are going to look very good because actually I only need a little bit of elastic. So the way we do that is to allow permutations up to a certain amount of time. So they'd only allow, say, a half hour to shift for an hour or maybe an hour and a half or something like that in either direction. We know there's going to be dinner time. I'm just not quite sure where it is. So we might allow a little bit of elastic. Okay, and when you do this, the idiot forecast no longer wins. But some of these other forecasts do rather well at this point because actually they can be bold enough to predict peaks, and so you're rewarding forecasting methods that go for peaks as opposed to penalizing them. And one area that I'd point out that if say you have a peak at I star, and so suppose we've got some peak, f has a peak at fi star, then if pi of I star is less than I star, then actually the peak forecast was too late. Pi of I star is less than I star, you're bringing it forward in your optimal permutation. So actually that says that you forecast the right thing, but you did it late. And actually for all sorts of reasons it might be that we want peaks, and we also want peaks to be forecast early. The reason being you might be charging up a battery or going to do something in smart control or something like that, and you don't want to get caught out where you're using the time before the peak to charge up the battery. It would be better if you had an early forecast. So we might want to add on an extra, say something here, which looks at the difference between pi I and fi and puts that in the sum in such a way that this would penalise us for, you know, the higher peak is forecast, the more penalty we'll have, and the later that the thing is forecast, the more penalty we'd have. So we could make up some functions there, and these functions, these norms, would be more appropriate, perhaps, in terms of evaluating methods for forecasting these spiky data. What we're doing is we're putting in some elastic in the first case and allowing us to change that. So we can have a quick look at how that works. Here we've got, I don't know, how many others, Steve? There's 1,000 houses or something like that on here. And I'm comparing it to flat forecast. So if you project it down to the bottom, if you're over to the left, if any of those houses are over to the left of 0, then the flat forecast wins over these two forecast methods we're doing here, which I'm not going to talk about. If you project it over onto the y-axis, if you're beneath 0, the flat forecast wins. So in actual fact, you really want methods which, you really want methods which get you up into this top right quadrant here. And you don't really want methods which sort of get you down here. And so what we can do is we can compare different types of forecasting methods and try and find ones that do particularly well on this spiky data. Why do we want to do that? Well, we've got another part of our project which is looking at the use of storage. And this could work either side of the meter. It could work in the road, or it could work at the substation where we could have some storage and we could intelligently turn it on and off. It could also work inside the home, where if you had any means of storage, you could turn things on and off. We've done some of this. We saw this slide yesterday. Counting Lab did some of this in that Kaggle competition and did very well there. And Billy Joe's here, so he can tell us all about that, tell you all about that over coffee as to how we manage that. But as soon as you think about these sorts of norms, then you start to think about algorithms that would optimize performance under those sorts of norms. So I'm there, right. So smart meters, time of day tariffs, new technology, and consistent behavior. That would give the consumer themselves some way of living their lives the same, but shifting their demand on the network in such a way that we could benefit from time of day tariffs. There's money to share there because suppliers can't sell you. Suppliers sell you energy at a rate that they can't buy it at certain times of day. So there's money to share there, and there'll be true benefits if people can do that. Actually, there's clearly a benefit for the regulator in terms of understanding the consequences of what we do in terms of policy, perception, and behaviour. And there's also quite a big benefit to our friends Scottish and Southern Energy's power distribution, who want to be able to know which part of the behaviour is to be expected and which part of the behaviour is to be unexpected. Thanks very much.
This was a suggestion about your forecast problem. Have you considered using the Kantorowicz-Rubinstein metric?
No, is it similar to this one?
It's somewhat similar.
Yeah, no, I'll have a look. Thanks.
Also a question on these, on the error measure, on the metric. How does that deal with the fact that you have very coarse time resolution? So if you have a very sharp peak and you shift by 15 minutes, your peak's going to look very different.
Yeah, we're stuck at the resolution we're going to get from smart meters, and we've been assuming, and I believe it will be the case, that it will be just this half-hour time resolution. So we're shifting in lumps of half an hour. We're not doing a kind of Mong problem where we're allowing the demand to split up. We're actually permuting the elements of the vector, and I think there's good reason for that. But I think there's a whole class of area here where we ought to look for norms which allow these bits of elastics, because we want to get the peaks right if we're going to be charging and discharging. So if anyone else has got ideas about this sort of thing, I'd be very pleased to hear them. Andrew?
I've always been of the opinion that when you're constructing a norm for how good a forecast is, that you ought to build a simple model that translates the forecast error into the quantity that is of interest to you. Yeah. In our case, it's money. So if you can say, getting the forecast wrong in this way costs me this much money, then the money is a very good metric.
Yeah, well, one of the things we're trying to do, we're trying to estimate how many networks do we think this sort of thing would be useful for. If we had some element of storage on a network and we could do the smart control, which admittedly is downstream of this, but we've got a team in systems engineering at Reading looking at that and doing very well with it. So actually we want to try and optimize our forecasts so that they're good for the controllers, and they do some other peculiar things too. But I think there's a question about money and effectiveness that says, you know, how many networks do we think in Bracknell could ever be usefully served by such a technology? And that's one of the things we're going to get to the bottom of. But I don't have the answer to that. Sorry.
In terms of control, actually, the final users, consumers, decide how to use their electricity.
Yeah.
Do you introduce some recommendations to electricity consumers, or it's all at the level of modeling and communication with the electric companies?
No, our vision is that there should be a passive customer, that it's only recently retired men that want to put their heads under the stairs every night and see how much money they're spending. And so we have this idea of having a passive customer and technology which simply uses storage to shift their demand, so that their demand on the network doesn't appear as their usage appears in the house. I think obviously you could advise, and there's things that you could say, but I think people will pretty quickly get tired of all that. I mean, you know, the evidence in lots of things says, I mean, it's interesting for about the first week, and then life returns to normal after that. So, but the same technology would work at a substation. If we had a substation that was in distress or likely to become in distress, then we could put some storage in. We could put something that just learned the pattern and the network, produced a rolling forecast, and then intelligently deployed the storage, charging and discharging in some smart way. The people downstream don't have to change their usage. In fact, it's better if they don't, because then they'll be more forecastable. But I think there'll be other networks where there are some of these volatile people who are potentially unforecastable. And if you get more than N% of those, then they're going to be digging the road up.
But when you are talking about storage, it is...
Can we maybe one question? So repeat.
Actually, my question is maybe a bit provocative, but is there really a need for individual forecast?
Is there really a need for
individual forecasting? I mean, for network management on the...
Well, there's certainly a need for forecasting at substations, because that would, you know, if you haven't got a forecast, you can't control any storage smartly. I mean, it's just oxymoron, that is, you know. But our curiosity as to how well this works for individuals, actually, if it does work well for some individuals, then they ought to have that chip. They should have that. They should have that as beneficiaries of all of this, because that would work inside their home. So I see that as a kind of, you know, as a benefit, that if customers had any means of storage and their behaviour was predictable and they have time-of-day tariffs, they're going to save money. They can't have that without a chip that learns their usage and then could shift things around in some suitable way, predicated on what tomorrow's usage or the usage over the next few hours is likely to be. And if they don't have that, we'll be randomly turning things on and off, which doesn't sound very smart to me. So really our focus ought to be on substations, but actually there's not too much difference from the substation to a single household. I've tried to argue provocatively. All right.
Okay, I think we have to finish.
Okay, thanks.
One question. Thank you very much.